Hi guys, welcome back to my channel. In this video, I'll be taking you through Jacobian transformation. So we'll be performing integral with a transformation, okay? So we're going to convert it from its variables to different variables. I have this problem for us to solve. It says evaluate this integral where R is a region and is an ellipse given by this equation, inequality, and using the transformation S is equal to this and Y is equal to that. So in Jacobian transformation, we want to convert our function f of x, y, a function of u, comma v. Okay. The very first step you have to do, just make substitution for your what? New variable. You're gonna have s squared. So you take everything here and you're gonna have square root of 2u minus the whole 2 over 3v. Please take note this v is outside, so it was a question mistake. So all squared, right, minus with 2u minus 2 over 3v all squared. No, this multiplying y with 2u plus 2 over 3v, right? Then plus our y with 2u plus 2 over 3v all squared. As simple as that, we do this expansion. So this gives me what? 2u squared, and it's minus 2, so minus 4 over root 3 uv, because 2 and 2, because of the square root sign, they'll come out and they'll multiply the external 2 to give us what? Minus uv. Then this will give me plus what? Root of, so that will give me plus root of, right, 2 over 3. But since I'm squaring, I'm going to cancel, so plus 2 over 3 v squared. Minus the expression, this difference of 2 squared, you have 2u squared, right? Then minus 2 over 3 squared, as simple as that. Then plus, so this is exactly this, but now it's plus, so I'll have 2u squared plus 4uv over 3, then plus 2 over 3. At this point, I'll have 2u squared minus this 2u squared go away. I'll have 4 over this, cancelling this. Then I'll have 2 over 3v squared plus 2 over 3v squared plus another 2 over 3v squared. So at this point, this gives me 6v squared over 3, that is 2v squared. Then I have this plus 2v squared. So I'm going to have 2u squared plus 2v squared. Meaning I've converted this to this, right? Yeah. The next thing is to find our Jacobi. To find our Jacobi is so simple, right? So d of x comma y over d of u comma v obviously is equal to the determinant. I'll put my u here and v here. So I'm going to differentiate this with respect to u, this respect to u for this side. This respect to u, I'll get square root of 2. This respect to u, square root of 2 as well. Now, with respect to v, I'm going to have negative square root of 2 over 3. With respect to v, y with respect to v, I get positive square root of 2 over 3. As I said, v is out, okay? Then you cross multiply our determinant. So our Jacobi is an absolute of what? This time this will give us 2 over root 3 minus the expression. This time this will give us minus 2 over root 3. That's going to give me absolute of what? 4 over root 3. So this is our Jacobi. So after getting the Jacobi, the next thing to do is to do what? Get our region. But our region is an ellipse, meaning that we cannot use the normal integral to solve it unless in the polar region. Okay, polar region. But before then, our new integral is now integral over the surface S of 2u squared plus 2v squared absolute 4 over root 3 du dv. Nicely. Now let's use polar coordinate to solve this problem. So to use polar coordinate to solve this problem, we're going to have integral, okay? And our surface now, we're going to have r and theta as the things we need for our parameters. So, to convert anything to polar coordinate, we need our range for r, our range for theta. We'll bring our Jacobi outside and we'll factorize the two out. 4 over root 3, because it will not be affected. And remember, this is an ellipse, okay? Let's see, analyze it well. So it's an ellipse, okay? It's an ellipse. So this whole thing is represented as 2u squared plus 2v squared. Is that not it? I'm going to take my 2 out, and I'll have what? U squared plus v squared all equals 2 for this side. So meaning I'll cancel, and I'll have my u squared v squared to be equal to 1. So u squared plus v squared will be equal to 1. And you realize that u squared plus v squared in the polar coordinates, I'll make it what? R squared equals 1. So my R will be 1. Therefore, the range for R is simply going to be what? From 0 to 1. But R is inner. Then our theta, because you are dealing with ellipse, it becomes a complete circle, right? It becomes 0 to 2 pi, okay? Once you get 0 to 2 pi, already you know you have u squared, v squared becoming r squared. Then our Jacobi for r is r d theta, r d theta, sorry. So r d theta, okay. R d